the homework is going to have you have two charges. And one of the charges is plus and one of the charges is minus. No, actually, I take that back. They're both minus. So, oops, wow, sorry about that. We've got at x equals 0, there's a minus 25. I believe it's micro, might be nanocoulomb, I'd have to look at it again. Another one I think is more, and it's 45. The numbers really aren't important. This one's at x is 5, but we're 2 meters, or it's 2 centimeters actually. 2 centimeters away from this charge, which means if this is 5 centimeters, we're 3 centimeters from this one. But this is number 2. Number 1 is just kind of like one charge. You're finding the electric field from 1. When you're finding electric field from 2 charges, just do them independently. Like pretend you put a little positive charge there. Remember, we did problems like that. You put a positive charge and find the direction of the, find the force, the net force on the particle there. We're going to do the same thing, but now it's an electric field here. There's nothing there, but there is an electric field at that location from this one and from this one. So if I call this Q1 and I call this Q2, I don't care about them pushing on each other. Yes, they'll repel each other. Nobody cares. We're going to find the electric field right here from Q1. So which direction is E1? Is E1 to the right or is E1 to the left? We'll pretend to put a little positive charge there. It would get attracted to the minus charge, so E1 is actually to the left. And you would find its value doing K. If this is a point charge or spherical charge, which it is, you can use K Q1 over R squared. So you can plug in K, you can plug in Q1. The distance is 2 centimeters, 0.02 squared, and get a number there. And then from the other one, E2, it's going to be, well, let's worry about direction first. Let's draw the picture. Pretend to put a little positive charge there. Who cares about this one? It would get attracted to the right. So E2 is to the right. So you'll get some number here. This one was minus x. This one's going to be plus x. And it's K Q2 over R squared, which is K Q2, and the distance was 3 centimeters. And get a number for that. And then this one will be positive, and this one will be negative. And that is how you would start working on number 2 of your homework. Number 1 is easier. It's just there's only one charge, and you're finding the electric field 3 centimeters above a positive charge. So just to be clear again, I will not give you questions where you have to find the electric field here from 2 charges when they're not perpendicular. I could, however, give you something like, that's the same one, something like this, or this, where the forces were, where the forces were perpendicular. So in this case, the forces were to the right and down. To the right and up, to the right from this charge, and the electric field is up from this charge. And you could add those together. It would be up and to the right, and you could use the Pythagorean theorem and inverse tangent. It could also give you this one. The forces were, the electric field was to the right and down. So those would be perpendicular already. I can give you those. I will not give you anything where they're not already perpendicular. I can also give you in a line, like in the homework. Those are even easier. You don't need the Pythagorean theorem or inverse tangent.